All right, so take a look at this thing, and it says, remember the question we asked was, what proportion of men in the USA are taller than 6 feet? Okay, or what proportion of men in the USA are taller than 72 inches? Okay, and we said 0.1867. And what this picture tells us is that about 81.8133, that's the proportion of men who are shorter than 72 inches. Okay, so I could flip the question around and say, what is the height where 0.8133 of men in the US are shorter? That's terrible grammar here, but essentially this is the question I'm asking. So what is the height? What is the height where I'm going to find 0.8133 of men being shorter than that height? Okay, or 0.8133 of men in the U.S. are shorter than this height. Okay, then. Okay, and what is that answer? 72 inches, right? And the answer is 72 inches. Is that okay? So let's just flip back and forth between the slides. So here I said, what proportion, so I could ask, what proportion of men in the US are shorter than 72 inches? And your answer would be 0.8133. Okay? And so now I just flipped the question around and I said, what is the height where 0.8133 of men in the US are shorter than the height? And the answer is 72 inches. Okay? So I could change this question and I could say, you know, what is the height where, okay, and this one you should be able to answer, where 0.5 of men in the US are shorter than the height. Okay, so everybody should be able to think of a number to answer this question. Okay, just read this. What is the height where we're going to have 0.5 or half of the men shorter than this height? Okay, you should be able to think of a number here. Don't shout it out. Does everyone have a number in mind? Or do we need another second to think about it? Can we think? I'm not sure how to read people's faces. Some people are like, oh my gosh, this is so easy, I totally got it. And other people are, I'm like, are we with me? I don't know. Okay. So I'm asking, what's the height where half of the men in the US are shorter than this height? Okay? All right, so go ahead and tell me, what is that number? 69.5, right? The mean height is 69.5, and based on our picture, half of the men are shorter than 69.5. And so the answer to this question is 69.5 inches. Is that okay with everybody? Yes. Okay. So let's change this up now. Okay. So instead of this awkward wording, we have a way to ask this question. Okay. So this question I could change it to, what is the height associated with the 50th percentile? Okay? And this is exactly the same thing as this. Okay? when I say 50th percentile, it's basically saying where 0.5 of men in the US are shorter than the height, okay? Rather than having that awkward phrasing, I just say, what is the height associated with the 50th percentile? So how would I phrase this first question where I get 72 inches? I would say, what is the height associated with what? With what percentile? The 81.33 percentile? 81, 81st percentile or 81.33rd? I don't know how to cardinalize the thing, okay? Okay? But we can turn the question into this. Is that okay? So far, so good? Yeah? All right, so let's make a real problem that will actually require us to do a little bit of math here, okay? No, okay, but this is what we got to do. All right, so what height, or what is the height? What height corresponds, I'm just changing the wording around a bit, what height corresponds to the, let's do 10th percentile. Okay? What height corresponds to the 10th percentile? So this means 10% of men, or 0.1 of men is shorter than this height. Okay, 10% of men are shorter than this height. That's what this question means. Okay, so how do we do this? So in this case, I've got to find the z-score, and then I'm going to turn the z-score into a height. In the other problems, I was given a height, and then I turned it into a z-score, and I took that z-score and I looked up an area. In this case, I have the area, or the percentage. I'm going to turn it into a z-score, and take the z-score and turn it into a height. That's what I need to do. So we're going to go to our z-table, and am I going to use the negative side or the positive side of my z-table? The negative side, right? Because I'm looking for the 10th percentile, which means I have to be below the mean, right? This height is going to be shorter than the mean, so I'm going to be in the negative region, okay? So what do I look up? I want to look up the number in the z-table that's going to give me an area as close to 10% as possible. That's what I want to look up, okay? So we go to the z-table, and try to find the area closest to 10%, or 0.10, and find the z-score associated with that, okay? Or find the corresponding z-score. Okay, so everybody has to go to their table, or I'll let you finish copying this, and try to find the value in your z-table that is as close to 10% as possible. Sometimes you get 10% exactly, or whatever percentage you're looking for. Most of the time you don't get that exact number. So try to find the number closest to 10% as possible. Note the area that you shade is always going to be positive. The area you shade is always going to be between 0 and 1. You can't You can't have a negative shaded area. So you're on the negative side of the table, that's correct. But the area that's shaded is always positive. So you're looking for the number closest to 10%. Okay. All right, did everyone find the z-score that gives me 10%? Okay, so what's the z-score? We should have negative 1.28, right? Z equal to negative 1.28. Did we find that? No? Okay. Huh? You did? All right. Well, it's a good feeling to be right. And it's okay if you're not right, okay? This is why we come to school and learn, okay? So remember, so if you looked up z equal to 0.1, this is not what you want to do, okay? Because this says I'm looking up distance from the mean of 0.1, and I'm finding the area with that. What we want is we want the area that's 10%, and we want to find the z-score associated with that. So the number I can find that's closest to 10% is this number, 0.1003, and it's on the negative side of the table.
So you looked through the whole table and picked that out?
Yes, I looked through the entire table and I picked this out. Now it's not very hard because all the numbers are in order, right? It's just like saying I have to look through the entire dictionary to find this word. It would be really hard if they weren't in order, but they are in order, so it's not so bad, right? So you're going to have to look through the entire table to find this one exact number, or the number closest to 10%. Okay? They are in order, so it's not so terrible. It would be terrible if they weren't in any order. It's like, I don't know, you know, what, yes?
So it has to be, the standard deviation has to be negative because it's on the negative side, right?
Yes, and I'll draw you a picture in a moment, and I think it'll help explain why we're negative. Okay, so anyway, this is the number I can find that's closest to 10%. I've got two numbers that are very close, 0.1003 and 0.0985, but this one is closer, okay? And that number corresponds to negative 1.28. Can we see that now? Okay, those of you who got it wrong, can we see that we're at negative 1.28? Okay, so remember what this is, we find the area closest to 10% and find the corresponding z-score.
So 1.2.
So you're in the row negative 1.2, but you're in the column 08. So you're at negative 1.28. Okay? Okay, and then so if this is my z-score, how do we turn this back into a height? Okay, so remember, z is equal to x minus mu over sigma. So if my z is negative 1.28, I'm looking for my x, and I'm going to plug in, what is my mu? 69.5. What's my sigma? 2.8. Good. Okay, so let's solve for x. Okay, so I got negative 1.28 is equal to x minus 69.5, or so solving for x. Okay, so we can all do algebra, right? So I get so solving for x, I get 65.916. Yes? No? Maybe, did I mess up again? 69 point. Okay, now I did it right this time. Okay. we're just solving for x, right? You've got an equation here, and we do algebra, right? You multiply both sides by 2.8, and then you now have negative 1.28 times 2.8 equal to x minus 69.5, and then you add 69.5 to both sides. Okay. And so we get that. Okay, and so this is the answer. What height corresponds to the 10th percentile? 65.916. So just about 66 inches. Okay, 65.9 inches corresponds to the 10th percentile. 916 inches. Okay, according to this. So nobody measures their height to the thousandth of an inch. So pretty much 66 inches, or if you want to be precise, 65.9 inches. But so 5'6". So about 10% of men are shorter than 5'6", 5'5.9", according if the numbers I used are true. Is that okay? So let's try another example here. All right, so same thing, okay? Men's height, mean of 69.5, standard deviation 2.8. I'm going to say, what is the height of someone in the 36th percentile? Oh no, don't do that. Okay, change of plans. 20th percentile. Okay, 20th percentile. What is the height of someone in the 20th percentile? Okay, so go ahead and take a minute and try to solve this. I'll draw a picture that might be helpful. Okay, so yeah, some of you might still be working or whatever. So the answer I'm getting is 67.148. Is that what we got? We feeling good? What is the height of someone in the 20th percentile? $67.148. Okay, so listen up. Listen up. What are we doing? We go to our table, and we want to find the z-score associated with the 20th percentile. So I go to the table, and I'm looking up the number that's as close to 20% as possible. Okay, and so I see 0.2005.1977. I say this one is closer, 0.2005. And that corresponds to negative 0.84. Okay, so z equal to negative 0.84 gives area equal to 0.2005. That's about as close as I'm going to get to the 20th percentile. Can we see that? Okay, and then so now that I have this, now I have to solve for the height. Okay, so I'm going to say, okay, z is equal to x minus mu divided by sigma So let's plug in the numbers I have. I got negative 0.84 is z. I'm looking for my x. I know mu is 69.5, and sigma is 2.8. So let's solve for x. Negative 0.84 times 2.8 plus 69.5 is equal to x. So I get x equal to 67.148. Okay? And that's our answer. Is this okay? All right, so you got homework problems, you got practice problems. Make sure you're comfortable with both types of problems, okay? You're given a measurement, a height or score or whatever it is, and you find what area is to smaller or greater. And in the other case, you might be given a percentile and you got to find the corresponding measurement. Okay. And then there's one more circumstance that applies to the normal distribution, and that is what area is in between two scores. And it's actually pretty straightforward. Okay, it's just double the work. That's all. Okay, just double the work, but the process is straightforward. Okay, so can I go to the next slide? Okay. So your best bet this week is just to practice, okay? If you got it, if you understand it, that's great. And if you don't understand it, I think with practice it will help. Okay, so let's just continue on with this men's height example, okay? So I got 69.5 here. And let's say I ask, what percentage of men are between, let's say, 5, 8, and 6 feet tall, okay? So this would be 68 inches and 72 inches. Okay, so what percentage of men are between 68 inches tall and 72 inches tall? Okay, so on my picture, 72 is bigger than 69.5, so I go over here to the right of 69.5. 68 is smaller than 69.5, so I go over here to the left of 69.5. And the question I'm asking is, how much is in between? Okay? So the way I'm going to answer this is, okay, is I'm going to figure out how much is smaller than 72, and then I'm going to figure out how much is smaller than 68. So I know my pictures are kind of crappy. Oh gosh, didn't want to do that. It's like, I don't know, whatever. Okay? So this is what I'm going to do. I'm going to find this area. I'm going to take this area minus this area. Okay? So this minus this. And then that will leave me what's in between, right? Which is what I want. I want to get this piece here. How do I get that? I'm going to find everything to the left of 72, find everything to the left of 68, and I'm going to do this area minus this area, and I'll be left with what's in between. Sound reasonable? Okay, so what do? I turn 72 into a z-score. 72 minus 69.5 divided by 2.8. I think we already did this one. I get z equal to 0.89. And the area to the left of z equal to 0.89 is 0.8133, right? So that's our area over here.
You found that from the table?
Mm-hmm. From the table. I look up, first I get my z-score, 0.89. I look up 0.89 in the table. And the area to the left is 0.8133. Okay, now I do the same thing over here. Z is 68 minus 69.5 divided by 2.8. I get z equal to negative 0.54. Okay, and so I look up z equal to negative 0.54 in the table, and the area to the left is what? 0.2946. So this area right here is 0.2946. Okay, so the area in between this area is going to be 0.8133 minus 0.2946. And I get the area in between is 0.5187. Okay, so the area in between. So all I'm doing is I'm taking this chunk, the area less than 72, finding the area less than 68, and I'm just subtracting this chunk off of this thing to get what's in between. So what percentage of men are between 68 and 72 inches? Yeah, 51.87%. So about 52%. Are there any questions? Does this make sense? Yeah? Okay, so you might see a question like this on the midterm exam also, all right? And it's not so bad. The midterm is multiple choice. In the worst case, just pick some letters and, you know. It's not the optimal strategy, but you might get a few questions correct that you wouldn't have gotten otherwise, all right? There's no penalty for wrong guesses, so just guess away. We good? All right, let's cover our last topic for the day, and that uses the second table, this binomial probabilities table. Okay. Again, all of this you'll get better with practice. Just like everything in life, right? First time you try something, you're probably not going to be very good at it. Binomial distribution. So in this case, this is also a random variable. We've got a random thing. The outcome is a number. And in this case, we repeat a random trial n times. Okay? There are three numbers you got to look out for. N, P, X. Okay? So we repeat a random trial n times. Okay? For every trial, something happens or it doesn't. Okay? Something happens, and this is arbitrarily called a success, or it does not. And this is arbitrarily labeled a failure. Okay? Now, we associate success with good things, but in this case, it doesn't have to be a good thing. It could be a very bad thing. It's just either something happened or it didn't. Okay? For every trial, something either happens or it does not. And that's it, right? And then each trial has the same probability, P, of a success. And again, arbitrary label, not necessarily a good thing. And we want to know the probability of getting X successes. Okay, so here's an example. Okay, I will flip a coin, or let me let you finish writing all of this down first, because I want you guys to understand this. So okay, everyone's good? All right, so I will flip a coin 10 times. Okay, each coin flip has probability equal to 0.5 of getting heads. Okay, what is the probability that the coin lands heads 4 times out of 10? Out of 10 flips. This is a binomial problem. Okay, we're repeating a trial, flipping a coin n times, 10 times. When I flip a coin, either two things can happen, right? Either the coin lands heads or it doesn't. So each coin flip has probability 0.5 of getting heads. And what's the probability that the coin lands heads 4 times out of 10 flips? Okay, so in this problem, let's identify what N, P, and X are. N is equal to what number?
4.
10, okay? What is P? P is the probability of a success, which we've arbitrarily called heads, or I mean heads we were arbitrarily labeling success. Okay, and I'm interested in getting how many heads?
4.
4. So in this problem I got N is 10, P is 0.5, X is 4. Is that okay? All right, let's try something else. Okay, so you illegally park your car five days during the week. Okay? But you like to live on the edge, so this is why you do it, okay? And maybe you figure the probability of getting caught is only 5%. Might be a low monitored area. Okay, so in this neighborhood it's like 90% or something, you know? But maybe in this area, the neighborhood, it's like whatever, right? Okay, so we'll say the probability of getting caught is 0.05 on any given day. Okay, what is the probability you get through the week with 0 tickets? Okay, this is also a binomial example, right? When you park your car, two things can happen. You either get caught or you don't. Okay, so in this case, the success is getting caught. Okay, not a success for you, but in the context of the problem, we have, you know, the probability that something happens, that happening is, we just call a success. Okay, so what is my n, p, and x in this problem? N is what? 5. P is 0.05, and x is 0. Is this okay? All right, so we can answer these questions because they're asking for probabilities. So with a binomial problem, you've got to figure out n, p, and x, and then once you got n, p, and x, you just look those numbers up in the table. Okay, now in a more advanced statistics class, they might give you the actual formula for figuring these out yourself, but we got a nice little table. We're going to learn the easy version of the binomial, where we just look it up. Okay, maybe in another statistics class you'd have to calculate these numbers and they wouldn't give you the table. Okay, but here we're just going to deal with the table. All right, so what you do when you look it up in the table, you look it up in the order nxp. Okay, the problem, you find n, p, and x, but when you look it up in the table, you're going to look up n, x, then p. Okay, so let's do the first one. N is 10, x is 4, p is 0.5. So the first column, we look for n and we go down and we see this ends at 8, so we go to the next page. So we go to the second page and we find n is 10. Okay, is everybody good there? And then what was my x? X is 4. So I go to the next area and I go to the row 4. So within n is 10, then I go to x equal to 4. And then I go to the column 0.5 for p equal to 0.5. And what is the number I have? 0.205, right?
Why did you start with n is 10?
Why?
Yeah. I thought we said n is 5.
I'm sorry, I'm doing my first problem. Flip a coin 10 times. N is 10, p is 0.5, x is 4, so I'm going to go, and we look it up in the order nx then p, okay? So we go 10, 4, 0.5, and I find 0.205 is my answer. So the answer to this problem, 0.205. Yay? All right. Why don't you try your second problem then? Okay, do we all get 0.774? Okay, n is 5, I go to the row x is 0, and I go to the column p is 0.05. So I go n is 5, x is 0, and the column 0.05, and so the number I get there is 0.774. Is that okay? All right, so let's, is this okay with the binomial? The hardest part in the binomial problem is figuring out, hey, this is a binomial distribution problem. Okay, that's the hardest part when dealing with the binomial, because sometimes probability questions look a lot similar to binomial problems, and you've got to be able to say, hey, this is binomial, this is, I'm doing a probability problem here. Okay, so I'm gonna do a couple examples here, and I'm not going to tell you what's what, and we'll ask you to find the answer. All right. Okay. There is a game of chance. Okay. Your probability of winning a game is 0.2. Okay, well, I'm going to say you play the game four times. Okay. What is the probability you win the game one time out of the 4 attempts, or the 4 plays? Okay, and then question 2 is very similar. Okay, game of chance. Probability of winning is 0.2. Play 4 times. What is the probability you win the first game and lose the remaining 3? And oh, we'll do one more. Game of chance. Probability of win 0.2. So you don't have to copy this every time. Play 4 times. What is the probability you win 3 times or all 4 times? Okay, so why don't you try that out? I'm going to pause the video if you're watching on YouTube, so pause it yourself. I'll try to figure out these answers here. All right, so again, everything with a little bit of practice. If you're not getting it the first time around, you know, you can rewatch this lecture, you can try the practice problems. There's lots of things. You got an entire week to figure this out. Don't be sad. Okay, so again, the hardest thing is figuring out what's binomial, what's not binomial. All right, so with binomial, okay, you just want to know the probability of getting X successes. You don't care about the order of the successes. You just want to get X successes after n trials. Okay? So in this case, these 2 questions, the first 2 questions, I purposely tried to make them sound similar, but also distinguish the two, right? So here we got a game of chance and the probability of winning is 0.2. You play the game 4 times. That's not a question. You do. You play the game 4 times, and we're asking what's the probability you win the game 1 time out of the 4 plays. So we don't care if you win the first game or if you win the last game. We just want you to win 1 time, exactly 1 time. We don't want you to win twice. We don't want you to win 3 times. We just want you to win once. Okay? So this would be binomial. Okay? And here I've got n equal to 4, p equal to 0.2, and I'm looking up x equal 1. Okay, so I'm going to look up n4, x1, p 0.2. And when I do that, I get 0.410. n4, x1, p is 0.2, and my answer is 0.410. So we go to the table, look up in binomial table. Is that okay? Over here, this one was a lot similar to a question you saw in your quiz. Probability of winning is 0.2. You play 4 times, same as before, but now we're asking what's the probability you win the first game and you lose the remaining 3 games. So here we have an actual sequence. It has to go win, then lose, lose, lose. So we have this exact sequence. So the win is 0.2 and the loss is 0.8. Each loss is 0.8, right? So it's 0.2, 0.8, 0.8, 0.8. And when we multiply all this together, I get 0.1024. Okay? And so that is my answer there for answer question number 2. Is that all right with everybody? Okay. And the last one, same thing. Probability of winning is 0.2. We play 4 times. What's the probability that you win 3 times or all 4 times? So in this case, this is binomial because we don't care about the order. We don't care, you know, when you win 3 times, we don't care if it was the first 3 or the last 3 or whatever. So here we got n equal to 4, p is 0.2 again, and we've got x equal to 3 or x equal to 4. So if I look up x equal to 3, I get 0.026, and if I look up x equal to 4, I get 0.002. Okay, so this is 0.026, and this one's 0.002. It's an OR probability, so I add them together, and I subtract off any overlap. But there's no overlap between winning 3 times and winning 4 times, okay? You can't have at the same time won 3 times and at the same time won 4 times. One or the other happened, okay? So there's no overlap to subtract, so here I just add the 2 together. I would subtract off 0 if we're subtracting the overlap, and so the total probability would be 0.028. Okay? So these are your answers, 0.410, 0.1024, 0.028. Yes?
Isn't it 3 out of 4? Win all 3 times?
Winning 3 times out of 4 or winning 4 times out of 4 is what the question was asking. Yeah. Wait, so
Is
it's...
that the question?
Yeah, that's what the question was. You're going to play the game 4 times. We're asking what's the probability you win 3 times or all 4 times? That's what we're asking. Okay? Okay, so with this, that concludes the stuff we've covered today. Good luck as you guys study. We'll see you guys next week. If you guys will be fine, all right? Just if you've been doing okay on the quizzes, study the quizzes, study the practice problems I've posted for Chapter 6. If you can get a grip on that, you should do pretty well on the midterm exam. So we'll see you guys next week. Good luck as you guys study.